Hello everyone. This is one problem from electric field. This is problem number 54 from Resnick Halliday Walker, 10th edition. In this problem, it said that an electron is shot with an initial speed 2 into 10 to the power 6, making an angle 40 degree with the horizontal from the x-axis. The electron moves through an uniform electric field which is towards the positive y direction. So that's mean electron basically will be deaccelerated after throwing from that, because the force on the electron would be basically that downward, right, since it's a negative polarity. We know a positive charge in the electric field moves in the direction of the electric field, a negative charge will move in the opposite direction. So that's why you can say that the force on this electron would be downward, as well as the acceleration would be also that downward over here. So that we can say that acceleration would be towards the downward direction. Fine. Now what they are asking, there is a screen to detect that electron. The screen is positioned parallel to the y-axis at a distance x equal to 3 meters. So that means this distance is 3 meters. Now, since the electron initially has some velocity, it will be moves in that direction, but it will be deaccelerated because the force on the electron is basically the downward. So that means it will moves it will create a trajectory and will be strike the screen. Since the acceleration is towards the vertically downward, there will be no acceleration, would be towards the horizontal direction. It is analogous to the projectile motion. Basically, this is a projectile motion. Now, they asked you to find out the velocity of the electron when it's going to strike the screen. That velocity we have to find out in terms of unit vector. So that means I have to express the velocity of the electron when it's going to strike the screen. This will be Vx I hat plus Vy j hat. So that should be the velocity of the electron when it's going to strike the screen. I have to find out that velocity over here. Fine. We can find out that Vx, since the electron has the acceleration only is the downward direction, there will be no acceleration towards the horizontal direction. It means that along to the horizontal direction, it will move at a constant velocity. So that's why we can say that Vx will be V naught x. So that means whatever its initial component, let me change the color. What was its initial horizontal component, it will be remain same throughout its trajectory, right? That we can also know from that projectile motion. Say this will be my V naught x, and there will be also a horizontal component, that will be V naught y. V naught y actually the initial component of the velocity along the vertical direction, and V naught x actually the initial velocity of the electron towards the horizontal direction. Fine. Now we can split that vector, because we know that this V naught actually 2 into 10 to the power 6 meter per second, and the theta naught actually that 40 degree, and that x is given, which is 3 meter, and the electric field, which is vertical direction, which is 5 Newton per coulomb j hat. Now we can find out this V naught x. So V naught x would be V naught cos theta, right? So that's when we can say that Vx would be basically 2 into 10 to the power 6 into cos 40 degree, which will give that the Vx would be 1.53 into 10 to the power 6 meter per second. So this is would be that velocity of that electron towards the horizontal direction. It will be initial and also the final component, because along to the horizontal direction it moves at a constant velocity. Fine. Now what about that velocity of initial component, which you can write V0 sin theta. If you put that value, then you will find out this V0 sin theta will be 1.28 into 10 to the power 6 meter per second, right? V0 actually, if you plug in that value, you can find out this is will be the initial component of the electron along to the vertical direction. Fine. We find out the Vx. Now we have to find out basically that Vy, final velocity of the electron after traveling that distance. So final component we can find out V0y plus Ayt. I find out V0y, I have to find out that Ay and the t. Then I can find out that Vy. If I could find out the Vy, then I'll be able to find out that V, that is the final velocity of the electron when it's going to be strike the screen, because we already know that Vx. Fine. Now how I'm going to find out that acceleration of the electron first? Since that force on the electron actually towards the vertically downward, then we can write down, say that Fy, which is the force on the electron, Q into E. That mass we can say that Ma, using the Newton's second law, F equal to Ma. From there we can find out that the acceleration of the electron would be Q into E divided by M. I know the charge, which is 1.6 into 10 to the power minus 19 coulomb. Electric field strength is 5 Newton per coulomb, and the mass of the electron is 9.1 into 10 to the power minus 31 kg. If you solve this one, you'll find out that acceleration of the electron, that would be 8.79 into 10 to the power 11 meter per second square, and this will be basically downward. If I write down in terms of vector, I will write down the acceleration of the electron. This will be minus 8.79 into 10 to the power 11 meter per second square J. So this is actually that acceleration of that electron. Or I can write down this is also the Ay. At that acceleration, the electron will move towards the vertical direction. Fine. Now what about the time? We can find out the time, which is the flight time of this electron. So it will move, whatever the time it will take if it is travel towards the horizontal direction, it will take exactly the same time if it goes in a that way. So that's why we can write, so the distance traveled by the electron along the horizontal direction, it would be x equal to be V0 x into t. This t would be also the flight of time of the electron. Then I can find out this t. So t would be x divided by V0 x, which is basically the Vx. So we find out the x, we know the x, which is 3 meter, and V0 x, actually that Vx, right? We write down that equation. Vx actually the V0 x, which is V equals theta. We find out, which is actually that 1.53 into 10 to the power 6. I'm going to plug in that value over here. It should be 1.53 into 10 to the power 6 Then I can find out the t, the time of flight of the electron, or the time it take to reach the screen. It will be 1.96 into 10 to the power minus 6 second. It's closely 2 microsecond the electron will take to hit the screen. Fine. Now I'm going to find out the vertical component of that electron at a time 1.96 second later. So then I can write Vy would be V naught y plus Ayt, which V naught y we calculated that one, which is 1.28 into 10 to the power 6 minus, it's minus because the acceleration is towards the downward direction, so that's why it should be 8.79 into 10 to the power 11. This is the acceleration of the electron, into time, which is 1.96 into 10 to the power 11. Now if you solve this one, then you will find out that vertical component of the electron, this will be minus 4.4 into 10 to the power 5 meter per second. This minus is indicating basically the electron already crosses its maximum height, so that's why its x component will be towards that direction, and when it strikes the screen, basically the x component will be towards that direction and the y component will be towards downward direction, so that's why it's a negative. We find out also mathematically that we can say the electron already crosses maximum height. Right? Now we can write down the velocity of the electron. Velocity of the electron when it scans the screen, that would be V would be Vx I hat plus Vy z hat, and Vx is 1.53 into 10 to the power 6 meter per second I hat, minus Vy is negative, that we find out 4.4 into 10 to the power 5 meter per second z hat. So at that velocity, the electron is going to strike the screen. That's the answer of this question. So they asked me to calculate in unit vector notation what is the velocity of the electron when it hit the skin. So the electron is going to hit the skin at 1.96 into 10 to the minus 6 second later. At that time, the velocity of the electron will be 1.53 into 10 to the power 6 meter per second minus 4.4 into 10 to the power 5 meter per second J hat. That will be the velocity of the electron when it strikes that screen. Okay, thank you very much.